Today, what we're doing is this webinar to introduce and unveil the future of fire stopping, which is a new solution that we've developed in partnership with the guys that I'm about to introduce. And this is where we're going to show some of the results of those, some of the background, the reasons why, and then from there go into how you can actually get your hands on it and what it does, etc. So fire stopping is the topic, and as I say, there's 4 of us actually on the session here. Unfortunately, Steph, or Estefania, to give her a formal name up here, Steph's webcam has decided to not work, even though it worked like half an hour ago. So clearly we're having a day of technical things, but hopefully they're behind us. So we have Steph from Laing O'Rourke, Evin from BDP, Simon you can see on screen, Evin you can see on screen, and then myself over here who's sweating profusely after that little hiccup. So what we will do is just carry on, and I'm going to do a little bit of housekeeping first, and then we'll get into the session. So this is a busy session. The limit was 1,000 for registrations, and I think we just topped that out just before we started, and there's several hundred of you on here just now. So when it comes to question time, we might have a few of those, but we'll come on to that. The session's been recorded. Once the session's finished, we'll share the recording on YouTube, and it'll be made available through links through the follow-up emails and stuff like that that will come out in due course. Beyond that, because of the numbers, everybody else's microphone is muted except for ourselves when we're actually talking here. The Q&A session is a dedicated part at the end of the presentation that we'll come on to. So as we're going through it, if you have any questions, you should see this little panel on the side of your screen. You might need to use the arrow at the top of that to enlarge it, but down on that highlighted part there, you can see there's an area where you can ask any questions. If you type them in there, they'll then appear on screen, and we'll keep an eye on those as we go through the session. The final bit though, just before we actually go into the rest of the session, is there's been a massive response to this webinar, and what I've got here is just a real quick poll, because what we'd like to find out is fire stopping something that you're generally interested in, or are you aware of it because you already use Solibri? So here we are. So this is the agenda. The intro, we're going to run through a little bit of background and then through various other bits that will be presented by both Evin and Steph. And then in terms of getting the resources and extension updates, that'll come back to myself and Simon, and then the Q&A session at the end. So if you want to skip on, Simon, thanks. So as a very brief intro, the questions that when we were talking about this that we were asked is why these 3 parties are involved in this particular project. I think it's fairly common for construction companies and architects to work together. That's, I'm sure, has happened in the past. But ourselves as Solibri, why we're involved is a little bit different in this case, and that's some of the information that's going to come on and be talked about as we go through the presentation. So you'll see the reasons why the 3 of us are involved together as we carry on. So at this point, we'll pass over, and it's over to Steph to run through the presentation and some of the background to begin with.
Hi everyone, I'm Steph from Laing O'Rourke. I'm really sorry that you cannot see me today, but I trust that you can hear me well. Thank you, Simon and Ken, for inviting us today to this webinar. This is a fantastic opportunity for sharing the successful collaboration between Laing O'Rourke, BDP and Solibri, especially on the development of this innovative design solution that will transform the construction toward fire safety design. Before sharing more detail what we have achieved, I think it's important to look back on the reason that they are driving the industry change. So if you remember, in the aftermath of the Grenfell disaster in 2017, the UK government commissioning an independent review on building regulation fire safety. As a result, a report was published in May 2018, identifying the needs for improving fire safety standards through early design consideration, through collaboration, improving competency of the duty holders, ensuring evidence of the fire safety solution that we normally know by industry as golden thread. The fire safety information for the golden thread is to be generated during design and construction and to be transferred to the building's owner and facility manager, who will be responsible to hold and maintain this information throughout the life cycle of the building. So last year, the Building Safety Act was published, so it's now enforcing the construction sector to ensure that fire safety solutions are fit for purpose and compiling more responsibilities. Because fire safety is a vast topic, so the solution that we'll be presenting today focus more about providing certainty to the design and the golden thread of information on passive fire protection for service penetration, which we usually call in our industry fire stopping. So why fire stopping is so important? Well, we know that the fire performance of compartmentation is often bridged with the creation of openings or aperture on walls, on floor for the passage of services. So when we have this aperture or opening created, and after the installation of the services, they must be sealed with fire-tested detail. So when these fire seals are correctly specified and installed, in the event of a fire, they can stop or delay the spread of the fire and smoke as well to other compartmentation, which can provide like sufficient time for the occupant to evacuate the building safety. So we can see why it's so important, why there's a big focus on fire stopping. Some historic challenge have been faced by the construction sector in regard to fire stopping, because to ensure the right level of design compliance and buildability that the passive fire protection require, without an efficient process in place, it requires a large number of resources for which projects do not have the capacity. Additionally, the design is usually considered too late to elevate standards and achieve the right level of certainty. So when the design is considered too late, this can lead to an inadequate design, contribute to the low installation standard, and consequently, in the end of the project, poor information to hand over. There is a large amount of information to be generated during construction and during design and construction. Therefore, like, without a lean approach, it will be laborious and resource intensive. So Laing O'Rourke, as a principal contractor, we looked at mitigating risk and inefficiency throughout the process. So we were looking for searching opportunity to leverage existing technology and use automation throughout the project lifecycle with the purpose and the responsibility of building and delivering safety. The design information is a key enabler of processes downstream. Therefore, like, the certainty and the reality of the information, of the design information, have to be guaranteed and accessible across all project stages. There are three main objectives that the digital approach aims to achieve. During design, we aim to achieve design certainty. During installation, our objective is to mitigate defects, or to mitigate rework, to provide like a higher quality of installation. And in terms of the handover stage, we're aiming to achieve consolidation of a reliable golden thread of information. But today we will be only focusing on how we have achieved our first objective by partnering with BDP and Solibri. Since the Everton Football Stadium project provides the opportunity to develop, test, and implement the new digital approach, I think it's fair to have a brief introduction to the project. For those who don't know anything about the Everton project, so this is a new stadium which is located on the banks of the River Mersey in Liverpool City. It's approximately between a mile and a mile and a half north of the city center. So this project is a significant generation project of this particular area of the city. And it is already acting as a catalyst for further high quality development around the area. So definitely will be boosting the local economy. The client of the project is the Everton Football Club, The construction costs of the project sit around £550 million, and the capacity of the stadium will be just under 53,000. The target completion date is to be opened for the season 2024-2025. So on this image, this photo was taken last week, so we are now halfway to completion. On the photo, you can see that the envelope is in progress, the roof stroke is well advanced. You cannot have this flavor from the photo, but internally, fit out and services have already started since the beginning of the year. Right, so the innovative solution that we're about to share was achieved through tremendous determination and commitment from Laing O'Rourke, BDP and Solibri, and especially work on a solution that can enable the wider industry. When this collaboration starts in 2021, other contractors and consultants were invited to be part of a steering group to support on the development to push the industry forward. But unfortunately, none has demonstrated real willingness to collaborate. So we hope that our example today will help to change mindsets and overcome industry fragmentation to improve the future of the construction industry. It's important to say as well that during the development and testing of this innovative solution, a number of people were involved by sharing different skills, knowledge, and different perspectives. And to be honest, this was crucial to ensure the practicality of the solution, especially in real project scenarios. And it was clearly identified that the power of collaboration can really help to solve problem solving and achieve innovation more easily. So I think it should be a lesson learned for industry from our example. As well, so we hope that this innovative solution will bring sophisticated simplicity by facilitating design validation, as well through engagement, collaboration, early design decision, to improve fire safety, to increase design compliance. And I will pass on to Evin.
Thank you, Steph. So, as BDP and Laing O'Rourke, one of the main factors to overcome was the complexity from a design point of view. The complexity in this case have multiple layers. The size and the type of the project is a major factor. The number of penetrations and variances result in this complexity to exponentially grow. In this case, Everton Stadium has over 15,000 penetrations. The image on the left on the slide can give you an idea of the complexity we're dealing with. The seals are the ones in red. And the other aspect of the complexity is the factors that impact the design of a single fire seal. These can be grouped into three main categories: buildability constraints, compliance constraints, and installation constraints. This slide highlights how the manual approach would be prone to errors as well as resource-wise, an unviable business model. So the main focus to manage this complexity was by automation. We developed tools for both creation and validation of each fire seal. All of the team members included in this exercise reviewed best practice guidances available to ensure that we delivered the best we could in line with these practices. From digital aspect, we reviewed the guidance to understand which parts can be delivered and validated through the models. Once we established a high-level strategy, it was now time for next steps. In this slide, you can see our methodical approach. The first action to achieve a robust automation was gathering of the data. When we say data, we are actually talking about the design constraints. For this, we engaged in extensive workshops, engagements, and technical documentation review of all the downstream supply chain. These were various mold manufacturers, sealing manufacturers, and fire stopping manufacturers. In this slide and the following slides, you will see the results of these engagements, defining the buildability constraints, compliance requirements, and installation constraints. To highlight the complexity that we mentioned before, as you can see, these constraints can include, it does include size limitations of openings, the distances between openings, the geometric positioning of openings, and service types, service distances, the performance requirements, as well as the installation requirements that define if access is required from one side or from both sides. Once we have defined these constraints, we then collated them into a matrix. From the onset of the project, the aim of both BDP and Laing O'Rourke was to develop a solution that would be applicable for multiple projects. And essentially, that would help the wider construction sector to achieving safer buildings for the people who are going to be using them. We wanted to create a tool that would develop and grow cumulatively with everyone involved. So with that in mind, we analyzed all this data, this project data, and developed this matrix to define actually the key factors that would be applicable for multiple projects and scenarios. These matrices then fed into our automation tools for both creation and validation. The automation tools were developed to capture early penetration and required information to be fed into fire seal design decisions. And of course, further tools were developed to automate the population of fire seal data, the creation of outputs, and management of data in general to ensure that the whole overall process is robust and ensure that the golden thread of information is achieved. BDP's and Laing O'Rourke's main focus was achieving building safety through design certainty. And as you can see from the slides before, the overall process is highly data-driven and heavily multidisciplinary. So we needed a process that would continuously inform the designers during the development, as well as ensure the final product meets requirements. And as with any process, the key aspect of ensuring quality is through validation. And to meet the demands of this complex workflow, we reached out to Solibri, one of our key partners, to develop this tool together. In our review, we separated these checks into two main aspects to ensure continuous feedback to the design team. We define them as early design and late design checks. And Steph is now going to walk you through how Solibri tool works with the first.
Thank you, Evin. So talking about early design, especially we're talking about builders' works. So I suspect maybe like a builder work can be perceived as just the coordination of the position and size of an opening on a wall or a floor, but there are a number of considerations to take into account. It must comply with manufacturer requirements, which can be subject to different constraints according to the wall type, the wall performance, if the wall is subject to crowd loads, deflection, and also to the position of the stud, and as well as the services type passing through, the service size and service material. So there's a number of constraints that we need to make sure like the builders will comply with. The design validation process relies, as explained by Evin, on a BIM model and also enriched with a granularity of information to perform the automated design compliance check. For the early design, which LOR in-house MEP design specialists are responsible, we have approached the design compliance in two validation stages. So the first stage is about metadata check. So we need to ensure the level of data required is present and it is quality as well. As well on this stage, we have included an early coordination check to identify that all services passing through a wall or a floor are covered by a fire seal or buildings work objects. The next stage is about compliance checks. So we confirm the overall coordination and buildability in compliance with manufacturer requirements. And in the next slide, we will show the level of compliance that we were able to achieve. Each check rule are fed by a database, a simple spreadsheet, which is easy to customize and update with the manufacturer requirements. So the 5 stopping rule are self-explanatory. so easy to set up, but guidance is now available from Solibri. What is vital to ensure is that components, and I'm talking about like 3D objects, grouped by classification. So for those with experience with the software, they know what classification are. So as I was saying, it's vital to ensure that classification match with the content of the database, which means the spreadsheets, and actually match when it is applying to the file stopping rule. So the next slide, we're going to show you some of the example we were able to check compliance during early design. So this particular example shows a pipe. If you can have a look on the right buildings work, you can see a pipe outside the blue area, so which the blue is a buildings work object. And the check has automatically flag any service that did not cover by the brick. So it did enable the team to have a quick response for those identified. This particular example enables to identify the incompatibility of services. And when I mean incompatibility of service, it's because it's some fire tested products will not allow service to share the same fire seal. So again, like a really good example how we can, with the design automation, we could identify those non-compliance. This example checks the compliance with the maximum size specified by the manufacturer. And usually the maximum size is constrained not only by the performance of the type, the wall type or the performance, but also based on the crowd load the wall is subject. This example check the minimum distance allowed between the buildings works, again with the same constraints as I mentioned before, wall type and crown load. This example here shows how we did manage to identify non-compliance with the minimum distance required to the compartmentation. Again, same constraint, wall type, and also crowd load. Okay, so on this check, we were enabled to confirm if the position of the buildings work were clashing with vertical and horizontal partition studs, even though those studs were not included in the model. So I think again a great feature from these fire stopping rules checks. The next example, it's about checking the clearance, the minimum clearance required for each type of services. And this example to check the minimum distance required between services passing through the buildings works object. This rule is particularly helpful to identify design change. So since it compared the metadata of the buildings work object or fire seal object captured at the point in time against the actual services passing through. Since evidence of design decision is a key element of the golden threads, Solibri enables to capturing design decisions and transfer this decision with the use of BCF Live Connector, which is not new on the software. But yes, it enables to transfer this information to issue management or communication platform, and it's really important so we can like have an audit trail of these design decisions. Another great feature from these rules is the option or the ability to report or export early design information in a structured format. So this information can enable procurement, early design decision, and also collect golden trend of information. Evin, I will leave it to you though.
So these are the lake design checks. Our lake design checks starts with, of course, metadata checks. These metadata checks are there to ensure that the information in the model is sufficient for further validation, as well as that it has all the data required to align with the code and thread requirements. The next part is the compliance checks. It's about ensuring, and it's in the name, compliance of the fire seals with the manufacturer requirements. So for everyone to understand how the rules work, as Steph mentioned, the rules work on a database. It's a simple Excel matrix that we feed from our initial matrix that we shared before into this Excel sheet to validate each fire seal for its compliance. The rule in here checks if the fire seal access requirements are met for installation. It checks if it has an accessible space on either side of the seal, reports if it has access on one side, on any side, or on both sides, and compares it with the requirement of the fire seal to determine if it complies. The rule checks performance requirements as well. It gathers the acoustic requirement from the hosting supporting structure of the fire seal and checks if the assigned fire seal meets these acoustic requirements. In the info box, it reports the acoustic performance required by the host and the acoustic requirement that the fire seal provides, and then reports if there's any non-compliance, of course. In this slide, you can see how it validates the fire performance requirements. As you can see, it's, again, similar to the acoustic performance requirements. It gathers the fire performance requirements of the host structure, validates if the fire seal meets those requirements, and reports, the minimum required value, the maximum required value. For those of you that certain seals, of course, have a minimum and a maximum range that it needs to validate. So it checks inside if those the supporting structures values sits inside those ranges. In this slide, the rule also checks the service types compliance. As Steph mentioned, certain seals only have allowances for certain service types, and it defines, the rule gathers what service types are passing through the fire seal, compares it with the service types that the fire seal allows, and reports if there is any non-compliance. Here the slide shows how the rule checks for a number of services. So for those of you who know and don't, some certain fire seal only allow for a single service coverage. So the rule identifies the number of services that are passing through the seal and validates if the fire seal assigned can accommodate these numbers, and reports where there is an issue of non-compliance by reporting what the info box is, and it says what the current status is and what the fire seal requirements are. Certain fire seals can only be a certain distance from the soffit. This is to do with the drop head detail requirements. I'm not going to go into too much detail here, but this in here, the rule checks the distance of the fire seal from the soffit and compares it with the required distance of the fire seal. In the info box, you can see it reports the required versus the actual distance, and of course highlights if there's any non-compliance issues. So we are continuously engaged in workshops with Solibri to further develop and progress these rules to achieve a robust automated validation, which Simon is going to give you updates of in the end. But just to highlight, as a result of this process, we are now delivering a lot more enhanced outputs, quite different from the standard pack of details that seems to be the norm. We provide elevations and plans for each fire seal with all the relevant data and reference documents needed for installation on site, and that would essentially be part of the pack of information that the end user would need for their facility management. Steph, it's yours.
Thank you, Evin. So the final slide, just about to share with you some of the KPIs we were able to achieve with an innovative design approach So a comparison was undertaken between two Laing O'Rourke projects with an approximate number of fire seal. So what we managed to achieve was at Everton, like the design was started earlier through engagement and collaboration to identify the design constraints and buildability requirements. As explained by Evin, this information is vital to set up the fire stopping rule to confirm the design automation check. We have also increased awareness and understanding of the requirement of a vast range of project stakeholders, which did reflect in achieving a higher design standard and consequently improve installation standard as well. The quality and the efficiency that have been achieved by reducing manual input to mitigate human error has been evident, and the design validation process as well has been improved from usually performing like a sample or percentage of manual check to the limited resources to 100% design check. We have also moved from an advisory set of drawings to a confirmed detail to each fire seal. So again, this mitigates some of the incorrect installation on site. We have also substantially reduced the number of engineering judgment to not deviate from tested fire stopping detail. And also, we have confirmed that from the increased awareness and understanding of the requirements, the overall design coordination has reduced from 12 weeks to 3 weeks. When I mention like this overall coordination is per construction zone, but we're not talking about the entire project, but a massive reduction. So this is a final slide from myself and Evin, and I hope you can see like from the complexity of the design, we managed to enable a solution that really helped to improve the compliance of the design. So I hope that the information, the solution will help you to improve design standard and also improve installation standard in the future.
Thanks very much. That's fantastic. The final part here of the presentation really is just how you get your hands on the resources and what they are, and a bit of an update that we've got coming up. So if you already have Solibri, these are the steps you can go through. If you don't have Solibri, there's contact details coming up at the end that you can drop us a line, and the guys can explain what the process is. There's various different options that allow you to get into Solibri. So drop us a line and let us know that. 2 steps, there's admin tasks and then there's user tasks. So from an admin point of view, it's really straightforward. You go into your account, you buy the licenses. They are free, but you go through the process of buying the licenses to register into your account, and then you assign them to the users, and that's it. The user tasks, and basically that's it there. There are a few seconds work. So you open the software, but you do have to have 9.13.2 or later for this to work. And as long as you've been assigned the extension, which is what we're talking about here, the extension is actually called BIM Coordination Plus. As long as you've been assigned that, then all you do is go into Solibri Office, you go to File, you go to Solution Center, and you click Install, and it is really, really quick. There's a second bit to it, which is a bunch of resources that you can download. So there's a sample file, a template, and another thing that I can't remember right now. I think it's an example file as well for the template. The other bits and pieces there, so the stuff that Simon's brought up on screen, if you want to see this in more detail and you can endure even more of me, which I'm fed up of me, these little screenshots, they're called 2-minute tech tips. So they literally are less than 2 minutes, but they go through the process of the admin tasks and the user tasks, and you can pick which one because you might be an admin but not a user, or vice versa. Final bit is in the very centre is a link to the main resources that explain all of the extension, how you install it, how you get it, all the bits and pieces you download, and then each one of the rules are detailed out. That's all available on our help centre, which is help.solibri.com. Of the QR codes, which are on screen and will be shared as direct links in the follow-ups, that'll take you to those direct pages. And those will be getting an update shortly with an update that Simon's about to talk about on the next slide.
Okay, thank you, Kev. Okay, so just to make people aware of the fact that we soft launched this software solution on the 10th of February this year. We've been working with Laing O'Rourke and BDP Pattern, to refine and improve the rules in line with the project that you've seen today. So for all the users that have already downloaded the extension already and are using it, then obviously these following changes are obviously very welcome. And those that have not yet downloaded it, if you can just bear these in mind so that we don't end up with a lot of support calls asking for this kind of functionality, that would be great. We're just finishing off these rules. We've got demo files to sort out, to update, and the documentation process to complete. So hopefully sometime in May we'll get these released. The first improvement we've actually made to the rules is on screen at the moment, which is as a result of the API user interface improvements. So every time we release a new version of Solibri, there are improvements within the engine itself, and in this case, the API functionality. So it's given us the opportunity to improve the service the classification selection, and also the requirements file path functionality within these rules. So before you had to actually put in manual text there, either copy and paste it. Now we've got a drop-down box for the classifications and for the requirements file path, which contains all of the drivers for the rules. Basically, in an Excel spreadsheet, you have a browse option that's there, so that's useful. So moving on, we've also created a new rule which allows you to check that surfaces are perpendicular to walls of fire seals in both plan and elevation. So that's the first thing. So you can see on the screen there where we have our services that are integrating with automatically found those center lines and worked out the angles of each of the services as they pass through the compartmentation. And on the right hand side, we can see some examples of some soil pipes basically that are going through at an angle. Now, the key part here is that we've also now integrated this into the support rule. And again, Evan showed a little bit of this on some of her slides, where we have the fire seals. We can also specify the extra column there on column Q for the relevant fire seal type in column A. We can specify whether it's designed for a perpendicular or non-perpendicular style service that would go through that. The key thing there is obviously it also takes into account the tolerance values, so anything below the tolerance is ignored. Anything between the tolerance and the angle limit is defined for the perpendicular and non-perpendicular checks. And then after that, basically, we have that angle limit, which means then it flags it up as a serious issue once it gets past that. So again, sort of improvements to the rules. The angle rule will work on its own as well to indicate those types of things, and also can work inside the support rule. Okay, so what was very evident with running these on a regular basis on this particular project is that we're now up to 15 rules basically. 13 of those you would configure on a regular basis. It was evident that all the filters and the settings for each of these contain very similar or the same information across the board. So you were having to fill these out over and over again, either by saving the filters. So what we've now done is created a new rule, and the new rule is really a way of collating that information and creating a standard set of common parameter names, basically. So in the example we have at the top there for the common parameter rule, we've created that common parameter name called common parameters 1. We can fill in the information within that rule. And then within any of the separate rules, then they have a drop down at the top of those rules. And if you select that drop down, then and select the common parameters, then all of the values and all the filters and the settings, basically, as you can see there, revert to inheriting. So they're inheriting the values from the common parameters names. And they have an override function as well. So if you wanted to, for instance, maybe you've got a requirements path that's slightly different just for one rule, you can override that by hitting the override button. Hitting the override button then changes it to a restore button if you want to put it back to taking it back to the common parameters. So a great way of ensuring that, one, we get consistency throughout the rules, and making it easier for people to configure on an ongoing basis. On one other last point there as well, on the common parameter rules, there is a option to notify changes. So if we change any of the values within the common parameter rules, what it actually does is you hit the notify changes button. Any of the rules or sub rules that use that common parameter's name at the top there in the image in the middle will then automatically then get rechecked if you hit the check model button. So the idea is that we don't have to then think about which ones this was used in when we make the changes. So again, a really good workflow piece of functionality. Estefania basically showed this on one of her slides. So we've taken the same sort of example of that, but there's a new rule, which is the reporting rule. So the idea was that this rule doesn't necessarily check anything hugely across the board. We expect that to be carried out with the checks prior to running this rule. This rule is almost like an extraction report. There is a few checks there that it does in the background where it actually grabs the services, things like that. But the whole idea is it'll grab the fire seals that you've got in your model, grab all the data that goes with it relating to the service types and also the supporting construction, and also other data that's required, and that can obviously help support the golden thread of information. So again, that's going to be added to that release as well. We've also updated the area rule. We had a rule which calculated the gross area of any of these fire seal components. It's now a volume rule as well, so it incorporates that volume functionality. And on the left-hand side, you can see the squiggly box. For all our rules, what it does is it gives us that really good, well sort of laid out piece of information that can go into any of the issues for indicating what the problems actually are for all the other rules. In this case here, it generates the list of gross areas and net areas for the associated fire seal. But that then gets passed through into the particular fire seal object as a set of parameters. So it's called custom information, which is so the rule is executing and then pushing the data into parameters, which we can then utilize within the information takeoff functionality within Solibri. So we could actually generate the summation of those areas if need be. So that's our sort of changes to the volume area and volume rule. Just a quick note there: those custom info values are not retained basically when you come out of the file. So you'd have to rerun that one to get the data into the custom info area in order then to report it. And finally, we've got a number of other updates which we won't show any sort of images to do with them, but the stud opening clash check we found with on support basically that any models that were a large distance away from the origin, it was affecting the rotation and the positioning of those studs, which we've now fixed. We also had an issue with the position rule, which was related to the fire seals. We've resolved this. This was related to the fact that it was confusing walls with floors. We've separated the filters so that you have to physically specify which of the floors and which of the walls. And in the support rule, a number of updates to that. So some of the spreadsheet values, top distance values, we can now put empty values in. Fire ratings can be 0 for non-fire rated fire seals. We've changed the way it looks for spaces either side for whether it's a single or a double-sided, both from the manufacturer's requirements and also from an installation purpose. And also we've incorporated an improvement to the way it checks the horizontal distances and the depth values that we can incorporate with that. So we've got optional depth limiter there as well, which is there. And then we also have the ability, because we're classifying services, it's important that we ensure that inline products like fire dampers, which would be in the ducts, basically are taken into account. So it's usual that you might classify the ducts and dampers differently within the classification, and then within our support rule you might want to then use the damper as part of the defining component. So we can now merge those elements together as long as they fully penetrate the fire seals, and then we can use them in the service type rule, which is there. So there are the main sort of key updates. We have other wish lists already for the and actual changes to do after this check already. So that will be continuing as we move along, as in multi-row evaluation, and also the changes which is an advanced proximity check, which takes into account overhangs and everything else. And finally, just to bring to the attention of everybody on the call, for our customers in the UK, we carry out free Solibri training, free Solibri office training every quarter. You can register for this either on an Eventbrite using the QR code you see on screen, or using the link at the bottom of the screen as well. And if anybody's interested in coming to see us, we are going to be available at the Digital Construction Week on the 17th and 18th of May. And you can visit us on the Nemetschek stand along with the other brands that are there. So that's stand D655. So we'd like to see anybody that's interested come and chat with us. So thank you for your attention, and thank you for your time.
We've got to say a massive thank you to both Evin and Steph from Laing O'Rourke and BDP respectively, and thanks for taking the time to put this presentation together that went so smoothly. Thank you once again for your time.